Hi everyone! Now we're going to work on the second exercise for this section, which is located in the same file, generic function exercises. So this exercise is going to be a bit more difficult than the ones we did before, because it involves some design decisions. Because of this, toward the end, I'm not going to tell you exactly which functions to implement, but instead I'll let you extend an API on your own in order to make it more expressive and user-friendly. I would like to take this opportunity to remind you that these exercises are not assignments. The goal is to review the material from the lectures, but also to discover new techniques. Okay, so we're going to implement a couple of methods for predicate, a wrapper around a function from A to Boolean. You know, the kind of functions we use for filtering. So the objective is to create a DSL, a domain-specific language, that lets us easily build complex predicates by combining simple ones together. A bit like Legos. So here's an example. I've created two predicates called isPositive and isEven that respectively check if a number is positive or even. Then if we want to create a predicate that verifies whether a number is both odd and positive, what we can do is call the method flip on isEven, which will reverse the predicate. In other words, it will check if the number is odd. Then we use the AND operator to combine the predicate with isPositive. And that's it. By the way, the AND operator is just a method on predicate, as you can see here. So we could have called it using dot and parentheses around the argument like we normally do for methods. So we could have said, could have put a dot here and parentheses around isPositive. But here I use what's called the infix operator syntax, so without the parentheses and without the dot. And this is something we can do for all methods that have a single argument. We shouldn't use this technique too often because it deviates from the standard syntax, which makes things more obscure. But it's convenient when we want to build a concise DSL, as we do here. So creating simple predicates is about as verbose as using bare functions. But what we hope is that this DSL will make the code of complex predicates much more readable, which is the most important point, right? So our ultimate target for today is to create a nice API to implement isValidUser, a predicate for a user class that I define here. So what we want to check is if a user is an adult, meaning that they are 18 years old or more, if their name is longer than 3 characters, and if their name is capitalized, meaning that it starts and ends with an uppercase letter. So we'll come back to this example later on, but now please pause the video and try to implement the first method on predicate AND. So to implement AND, we need to return a new predicate. And since it's a case class, we can write predicate, and between parentheses, we're going to define the input value. Then we'll apply the eval function from the current predicate, so this one, on this value. This will give us a Boolean. And we're going to call the eval function from the other predicate. So we'll do other.eval value. This gives us a second Boolean. And we combine these two using the AND operator. Now the question is, how do we test AND? We can write a couple of test examples. Actually, we would only need 4 examples to cover all the possible cases. One where both predicates are true, one where both predicates are false, and 2 examples where one is false and the other is true. Basically, the 4 examples we have here, and that would work. Let's try this. So let's copy this, and let's go to our test exercise. We'll copy them here and convert them into an assertion. Let's run the test. It works. Perfect. Now, could we use a property-based testing instead? If so, how would you do it? Please pause the video and try to write a property for AND. Okay, so let's try, let's create a test. Let's call it predicate and PBT. I don't know yet what we're going to test. We're going to use for all to generate some random inputs. So which random inputs do we want to generate? Well, we want to have two predicates to call n on. So let's try to generate two random functions. So let's call it eval1. It's going to be between int and boolean. Int doesn't really matter. It needs to have some kind of input. Eval2 is also going to be the same, int to boolean. And at some point, we'll need to call these two predicates, so we'll need also a random number, so a random int. Okay, so first step is to wrap every single int to boolean function into a predicate. So we'll say val p1 is a predicate for eval1. p2 is a predicate for eval2. And what we want to do is to combine p1 and p2 together and call the eval value, the value on this. So we could say dot eval value. But I don't know if you notice, I also define an apply value, an apply function on predicate, such that we can say p1, p2, n, and just pass values straight away. So this kind of goes into this DSL syntax to make it look like a real function. Okay, so now what will it be equal to? When will it return true? Well, it will return true if p1 on the value return true and p2 return true, right? But this is actually the code we wrote for n. So this is an issue we have quite often with PBT, with property-based testing, is sometimes it's very difficult to write a test that don't duplicate the implementation, which isn't very helpful, is it? So what could we do instead? So maybe we could try to find like a special predicate, then when we combine it with n, give us some kind of predictable result. What could it be? Maybe something that returns a constant. So let's define false. That will be a predicate that for any input will return false. And we can make this predicate parametric, so because we don't care about the input type. It will work for all input types, right? So what happens if we combine p1 with false? What will we get? Well, we should get false, right? Because n expects both sides of the expression to be true in order to return true, and false will always fail. So we know that this predicate, this expression will always fail. Okay, that's one test. We could repeat the same process with the reverse of false. So a predicate that always succeeds, that always returns true. So let's call it true. And what happens if we, true. What happens if we combine p1 with true using AND? Well, true is always going to return true. N expects both sides of the expression to be true, so it's going to be the same as p1 dot value. In other words, it's a no operation, a no op. Let's run the test. Great, it works. Cool, so now let's go back to the exercises and let's try to implement OR. So please pause the video and try it out. So to implement OR, it's going to be very similar to AND, right? It's going to be the same thing, except that instead of using AND as a Boolean operator, we'll use OR. That's it. Now, how did you test OR? Well, we can use a very similar testing strategy. So let's copy-paste this test. Let's make it for OR. And now what do we expect? If we combine, oh, by the way, I forgot last time, but we can actually remove P2 because this we don't care about it, and same here. We only generated one random predicate. Okay, so what happens when you combine P1 with false using OR operator? Well, OR expect any side of the expression to be true in order to return true. false will always fail, so we know that this is equivalent to p1 dot value. What about p1 or true? Well, true is always going to return true, meaning that this expression will always going to return true. Let's run the test. It works. So both testing strategies, example-based and property-based, are equivalent in terms of coverage here. We only needed a couple of lines in both cases to ensure the correctness of the function under test. However, I still favor property-based testing because it allows us to discover useful facts about our API. And thanks to these properties, we have extended our mini library with two special predicates, true and false, which may very well be useful to other users of our API. For example, at some point we may have a method that takes a predicate as an input, and if we pass true, we will clearly express that we want to keep all the inputs, or the opposite for false. Now, in order for these predicates to be reused by other people, we need to move them into our main code. So the question is, where do we put them? So I think these are good candidates to go to the companion object of predicate. Because in Ch02 we cannot have values as top level, we cannot define values as top level definition, so we have to put them in an object or a class. And these objects are predicates, so I do think that the companion object is probably the best place for them. So let's go back to our code. We'll define an object predicate, which will be the companion object of predicate. And we can define these two constants here. Make sense? Okay, now let's move on to the last function we haven't implemented in our API, flip. So flip is a method on predicate that basically reverses the property. So if the predicate was going to return true, now it will return false. So now please pause the video and try to implement it yourself. So to implement flip, we're going to create a predicate, define an input value, put an arrow, as usual. Then we need to call the eval function with this value. This will give us a Boolean. And we want to revert this Boolean to transform it. If it's true, we want to make it false. If it's false, we want to make it true. And to do this in Java or Scala, we can use the exclamation mark. And that's it. Now to test this function, let's open our test file. And what are we going to do? I think for this, it's enough to have a couple of test examples. So we can say, is positive of 5, oh, actually, is positive flip 5 should be equal to false, right? Because normally it was true. And the inverse for -5. So we'll say true here. Let's run the test. It's important to have two tests because flip could very well return a constant. So we need to verify that it doesn't return always the same value, like false and true in this case. We don't necessarily need to test with is positive. We could have tested with, for example, using our predicate.true and predicate.false. This would have made things probably a bit simpler to understand what was going on. So this predicate should always fail. We flip it, it returns true. The 5 minus 5 doesn't really matter now anymore. We could have said 0, 0, or in fact, we could even have used this empty parenthesis, which represent units. It's a type, it's a bit equivalent to void. It's something that has only one value. Let's run the test. Yeah. Anyway, all of these cases are completely fine. Okay, now let's try to implement a predicate in a real-world example. And let's see if our predicate API is fit for the task. And if not, it will be a good starting point to discuss how to extend it. So we're going to go back to isValidUser, the predicate we saw at the beginning of this video. So as a reminder, we want to check if a user is an adult, meaning that they are 18 years old or more, if their name is longer than 3 characters, and if their name is capitalized, meaning that it starts with an uppercase letter. So I'll let you pause the video and try to implement isValidUser yourself. Okay, so as we've seen before, we can create a predicate, define an input user, and this should return true if this user satisfies the three criteria defined above. So let's check that this user is an adult, so its age is greater than or equal to 18. Then its name has a length greater than 3, greater than or equal to 3. And then we want to check if his name is capitalized. Unfortunately, there is not out-of-the-box method to check if a string is capitalized. But there is a function to capitalize a string. So what we can do is do user.name.capitalized and check that it is equal to user.name. So in other words, we check that it's a no-op, a no operation. So let's write a test for this. We can even copy-paste these guys here. So we'll say test predicate isValidUser. And we'll convert each one of them into an assertion. Let's run the test. All good. Now let's go back to the exercises. Now there is a thing a bit annoying about this example, is that we started this predicate class under the assumption that it will help us to build complex predicates out of simple ones. But in this example, we didn't use any methods from the predicate class. Could we try to do so? Yeah, we could define a predicate for each criteria and then use the AND operator to combine them together. Let's try that. So let's try to define a predicate to check if it's an adult. So we'll say val is adult. And this will just check if the age of the adult is greater than or equal to 18. Then we'll have another one to check that the length is greater than or equal to 3. So we'll say is username longer than 3. Not an amazing name, but it should work. So this will be predicate username length greater than or equal to 3. And then we'll have a third one to check if the username is capitalized. Let's see if I can type it. Yes. So with the username.capitalize equal name. Here we're in a case where actually we can't use the underscore syntax because we have to use the input twice, here and here. So it means that we have to define it and replace each underscore with a user. So this was one of the limitations we saw before with the underscore syntax. Okay, now that we have these three subpredicates, let's refactor isValidUser this way. So we'll say isAdult and isUsername longer than 3 and isUsername capitalized. Let's run the test. It works. So this approach is a bit more verbose than the last one, but I would say it makes the code more readable because we name each criteria. Now, you might argue that we could have done the same thing without the predicate class. For instance, we could have defined a method and created 3 Boolean variables, one for each criteria, and this would have been equivalent. So the result is a bit disappointing, isn't it? But maybe it's because our API is missing certain useful methods for that particular scenario. So can you pause the video and think for a few minutes how we could extend this predicate API for this specific use case? So this is a bit tricky because it's really open. There are many ways we could potentially do it. But please, give it a try. So there are a few things that annoy me here. Let's tackle them one by one. First, we're checking almost the same thing in those two predicates. In the first one, we verify that the age is more than or equal to 18. And in the second one, that the user's name is longer than or equal to 3. So in both cases, we use the same comparison function, bigger than or equal to. So could we write a predicate that captures this comparison function and then somehow transform it so that we can apply it to different targets? In our case, the user's age and the length of their name. Let's try. So first we're going to create a predicate, let's call it is bigger than, for the bigger than or equal to. This is going to be a predicate of int, because that's what it takes as an input. And the code will say basically this, greater than or equal to. It needs to be greater than or equal to some value. So let's take an input, let's call it min. So this will be the value we use for the comparison function. Okay. So now that we have is bigger than, somehow we want to use it in the code of isAdult, right? Ideally, we would have something like is bigger than 18, but this is a predicate of int, not a predicate of user. So we need to apply some transformation to it. So let's try to create a function. Let's call it foo. We don't know what it is. But this foo is going to transform is bigger than 18 into isAdult. So what's going to be the code of foo? What is the input type? It takes is bigger than, so it's a predicate of int. And then it's going to return isAdult, so a predicate of user. Okay. So how do we code this? We'll say predicate, we take a user as an input. Then somehow we'll need to call the eval function from P, but this needs an int. So what we need to pass is the user's age. So we'll say user.age, right? Okay, let's try to run the test to see if we haven't broken anything. Okay, all good. Next step, we're going to repeat the same process for is username longer than 3. But except this time we need another update function because it's not going to be exactly the same. So let's call it bar. So bar will be the same type. It takes a predicate of int, a predicate of user, but the transformation is different. This time we're going to do user.name.length, right? Okay, here it needs to be called bar. Let's run the test. Cool. Everything's working. Okay, so now we can see that foo and bar are almost the same function, right? They both take a predicate of int as an input. They both return a predicate of user as an output. The only difference between the two is what do they do with the user. How they zoom into it. The first one, foo, zoom into the age, and the second one, zoom into the length of the name. So in fact, we could try to parameterize foo to take a function, like a zoom function, that will take a user and will somehow extract an int out of it. And now we can call this zoom function on user. This means that isAdult now is going to be foo of .age, and we can refactor is longer than 3 to use foo.name.length. Nice. So now we don't need bar anymore. We managed to generalize these two functions. What can we do next? Well, if we look at the code of foo, there is nothing here that is really specific to user or to int, really. We don't really care about them. These types have to match. So, we need zoom to take a user, and we need eval to take the result of zoom. But we don't really care that they are user and int. So we could try to generalize them. So let's call it from and to. So int is going to be from, and to is going to be user. And still compile. Let's run the test. So this is a good sign. When you see some code that is completely generic, let's use type parameter instead, because this will clearly tell all the users that we don't really care about the actual values in the type. So it's a good documentation. Okay, what could we do next? Well, this syntax is a bit annoying to say like foo is bigger than and then say underscore age. Ideally, we would use a more OOP syntax, something when we'll say dot foo age. So in a sense, it's the same thing, except that it's easier to discover. So it means that we somehow need to define foo as a method of predicate. So let's try that. So we'll go here. Now we don't need this predicate of from anymore because we are within the class predicate. So we can remove it. We can remove the type parameter from and replace it by a, the type of predicate here. And instead of p.eval, it's going to be this.eval, or we can remove the this dot, as we have done before. Okay, pretty easy refactoring. So it means that now this should compile, and let's refactor is username longer than 3 to use the same syntax. Let's check again that we haven't broken anything. All good. Now the question is, what should we call this function? As foo is not the best name for a public API, right? So what would be your choice? It kind of looks like a map function, doesn't it? So if we come back to pair over there, map here takes a function, an update function from A to 2, but in our case, foo takes a zoom function from 2 to A. So foo is like map, but backward. Functional programmers often call this function contra map, which stands for contravariant map. So we can refactor it to contra map. So it's a bit unusual. Most generic types we see in practice have a normal map function. But in some cases, like for predicate, map goes the other way around. And actually, it's impossible to write a normal map function for predicate. Please try. It will be a good way to see this for yourself. Okay, so we managed to demonstrate the first point I raised about the relationship between isAdult and isUsername longer than 3. Now the second point relates to the hierarchical organizations of predicates. So if we look at isValidUser, we see that it's composed of 3 subpredicates, but it doesn't tell us anything about how those subpredicates are organized. For example, we don't know that the first predicate targets the user's age, and that the last 2 target the user's name. So could we expose this information in our API? Meaning, could we somehow group those subpredicates by field of users? So for example, we may want to do something like by underscore name. So this is not, it's not going to work, but just to show you what I have in mind. And this will be a predicate of int, and we'll combine it with by underscore age. I was wrong. And this will be a predicate of string. This way we'll clearly express that, the first predicate targets the age and the second predicate targets the name. So do you want to give it a try? Please pause the video and have a go. Okay, so what we can do here is to try to define this method by. So what does it take as an input? It takes a function from users to something. So it's going to be the zoom function kind of we have before. So this takes a user and it goes to something. We don't know what is it. So let's say 2. So we have to make it parametric. And what does it return? It takes a second argument. So this is going to be the subpredicate. And this subpredicate is going to be a predicate of 2, right? And it will return a predicate of user. Does it make sense? So now what will we do here? We'll say we create a new predicate. We are going to first create a user, call the subpredicate, and then we need to zoom on the user. Which looks like exactly the code we wrote for contra map, doesn't it? So actually maybe what we could do here is to say subpredicate contra map zoom. Yeah, seems to work. Perfect. Okay, so now we want to replace each triple question mark with the real predicate. So here what is going to be? So we want to check that an int is bigger than or equal to 18. So we already have a predicate for this, is bigger than 18. Okay? Now here we want to check that the user's name is longer than 3 characters and that the user's name is capitalized. So let's write a couple of helper methods. So we'll say is longer than. So this is going to take a min, and it's going to be a predicate of string. Longer than. And what we want to do is basically it's going to be is bigger than min, and we'll contra map it using the length. Yeah? And then we'll do another one for is capitalized, except that this one doesn't take any parameters, so it could actually be a value. And this is going to be, so here we actually need to write the code from scratch. So this is going to take some text, and we verify that when we capitalize the text, it's the same as the original text. So now isValidUser will be is longer than 3 and is capitalized. Quite nice, isn't it? Now, by is a bit annoying because it's really hard-coded to user. We could try to make it generic as well, right? So we could try to say from right? The code still compiles. I know actually it doesn't, and in fact even IntelliJ told us so. And if we look at the error message, what does it say? Missing parameter type for the expanded function. And we can see that here the problem is that it can't figure it out what is the type of the underscore here. So it's more like a type inference issue. So here what we could do is to say we could try to define the user here. But here we run into another issue, that a limitation of Scala is the fact that you cannot say that partially define a type parameter. So you cannot say from needs to be a user and I let you infer too. There are some tricks we could use to make it work, but by default it doesn't. So it means that if you're in a situation like this, you actually need to define the two type variables for it to compile, which is quite annoying. So what we could do for now is kind of roll back our type inference, or change to by, and just keep it like this. We could say, actually this could be by user, just to make it clear that it is a specific function for users. So it's not exactly what we wanted, but it's pretty close, right? And I think the most important point is that we managed to group the predicates by field. And now we can clearly see that these two subpredicates applies to the user's name, and that only one applies to the user's age. So it's not exactly the syntax we had in mind. Nonetheless, I believe this was a worthwhile refactoring, because it pushed us to create reusable building blocks such as is bigger than, is longer than, and is capitalized. These predicates capture conditions on simple types like int or string, and thanks to contramap or by, and the rest of the predicate API, we can easily transform and combine them into more complex predicates, like we did for isValidUser. So we also encountered a few type inference issues. This is quite common with functions like contramap or by, because the update function or zoom function is backwards, meaning that we need to start from the bottom of the hierarchy with predicates of int or string, and then work our way up to classes like user. So there are some tricks we could do to make the API more friendly. They mostly help us get around type inference limitations that should hopefully get fixed or improved in Scala 3. So that's why I don't think it's worth spending more time on this for now. Still, if you're curious, I'll put a couple of ideas in the comment section for you to play with. Okay, so we are done with Predicate. I hope you enjoyed working on an API that is probably a bit different from what you're used to, as seen with the contra map example. It was also a good opportunity to design an API together. This is something I think is quite important because we generally see APIs once they are fully fledged and everything is working. And we often ask ourselves, wow, how did they come up with this? They must be geniuses. But in reality, it takes lots of trial and error and lots of refactoring before we arrive at a solution that we like. So it's a very long and iterative process that takes years to master. Fortunately for us, we have two fantastic tools, parametric types and property-based testing. So that's it for now. Let's take a quick break before we move on to the third and last exercise.